Welcome to the another session in Frontiers in CFD. So the complete tutorial of for the CFD simulation of lithium 5 cell lithium ion battery pack with Serpentine flow channel. So we'll discuss about how the geometry has been prepared with the help of ANSYS design modeler, how the sketching operations has been useful in order to do some extrude operation and later on preparing the whole pack. Generating mesh name selection, the important things which are to be remembered while doing this. So this is discussed during the tutorial, and how the boundary conditions are applied, where the boundary conditions are applied, what things need to be considered when we are preparing the geometry so that there will not be any tedious task of applying the boundary conditions in the setup. So welcome you to the complete tutorial of the CFD simulation of lithium-ion battery pack, especially the fluid flow which is taking place through a serpentine flow channel. So let's go back to geometry. I actually prepared the geometry first in order to reduce the time which is required in the video. So the geometry is already been prepared, and accordingly we'll go on to discuss each and everything which is related to geometry first, and then we'll proceed with the next part. So right now we're also running the simulation also. So you can see the color contours which are available here on this, and it is around 3300 around time steps iterations have been performed. So let's go back to the geometry first. How the geometry has been prepared, so that is very important thing or critical thing in order to proceed with. Just take a look of this geometry first, how it is. Now first of all, what is done is, if you see on the left hand side, I have selected one plane, that is ZX. So you can see on the ZX plane the one sketch has been drawn. So the purpose of providing a sketch is to have a kind of geometry which is having some kind of arbitrary curves over here, this kind of pattern. So it is not that possible with the primitives, and that's why a sketch has been prepared. So there is one motto behind it. Now next thing is, if you go back to the sketch, sketch has various things. One, it is the first circle which has been drawn of 26 mm. Then second one, this is the second, third one, and this is your the fourth one. Okay, so likewise the things are been done over here. Another thing is, you just see the dimensions which are been available. So this is what is 6, so 3 here and 3 here. So this is actually the channel through which the fluid is likely to flow. Now this is the first step in doing it. The cylinders which you are observing right now are been done later. So you can see one more cylinder which is over here, this is there, so which is generated after the we can say the sketch. So first of all we have the sketch, which is only this part. If you look at the sketch, only the yellow highlighted portion it will be visible. In that sketch you can see the various curves are there. So let us suppose this is curve R42, it is 13. So throughout wherever you will see all these curves, like these are all 13. So this is these are all 13. So that is one thing which you need to take care of. This is the whole dimension, whole diameter is 26. Okay, the whole diameter is 26. So normally whatever the curve which is obtained over here is we are taken as radius equal to 30. So this is same at one this and this location. So this is the first task, is just preparation of sketch, that is a yellow outline which you are right now observing. If you want to see the dimensions, you can see here, um, all of them are 30. This is 19. This is the center distance between the two cells. Okay, so that is been specified over here. Then the end to end distance, that is 114. Again this is also equal to 114, so that same thing which we had specified. Another H58 we already specified, it is 6 mm. So that is all through done through the sketch. So as of now the part of the sketch which we are observing is this one. Now next thing is, what the operation which is done is the extrude. So what is done is, you want this geometry to be extended in positive y direction. So you can see the extrude operation which has been done over here is this one. So it has been taken as 60. So as per the specification of lithium ion, you can take it. Normally it is around 60 or 65. You I have take it for a reference as a 60 over here. So that is one thing which we have done. So we have actually extrude the sketch which we have over here. The sketch has been extruded in positive direction, that is in the y, and you see it is 60. So accordingly the extrude operations has been done. Now once this extrude operation is done, in extrude operation you will not at all see these circles which are available here, only the outline which you are observing, this one, as I said in the sketch, whatever the yellow outline you are observing, that will be the only part when you are having the sketch. Okay, so next is the extrude operation has been done. So you have extended this object in the positive direction of y as per the dimension which we had. Now let's, what it has been done is we had tried to introduce one cylinder. Now which is this cylinder over here? Cylinder is right now which you are observing, it is actually the uh, if you see the radius over here is 10, so diameter will be equal to 20. So if you remember, if you know the, say, the diameter of lithium ion cell, it is around 18 mm, and here we have it is 20. So what is this? This is actually your casing part which is covering your say lithium ion. So let us suppose whatever the fluid is flowing, we don't want a direct contact of the fluid with respect to the exact cell, so there can be some kind of casing which has been provided, and the casing will go on to dissipate it to the surrounding. So this is one of the purpose over here. Or sometimes if you see the actual lithium ion battery pack, there also you will see such kind of things. Okay, so this is one, the cylinder which has been generated, this is on the outer side over here. Next thing is another cylinder is generated, again with the same dimensions 10, just the orientation has been changed with respect to your center. So origin x component is kept as 2.5. Okay, where is the plane 4? The plane 4 I have taken as a center, so that what will happen is we'll be able to take it as a reference quite easily, because you may take xy is also one of the plane which is on this side, but taking this 5, say, equivalent lithium ion cell, drawing that will be quite easy to involve a plane after involving a plane, and that's why the plane has been involved over here. So the base plane for this is be taken as yz. So this is yz, you can see here the base plane is taken as yz, so that we say you can either have the object in to the left of this or to the right of this. So based upon that, a cylinder has been generated. This is the first one. Now the plane will be useful for we say drawing the other cylinders. So this is the cylinder 2, then cylinder 3, this is on this side, cylinder 4 and cylinder 5. So we have tried total 5 cylinders over here. So cylinder first was generated, and after that the plane is generated, so as to make it convenient to draw it on the left hand side as well as on the right hand side. So accordingly, if you see this one, uh, slightly you can see the changes here. X component is 2.5, x component is here, over here. Then you see this, the next one, again it is minus, which has been specified over here. The z component is 38. Now one thing which is to be understood over here is this is your xyz, and here also you need to observe the coordinates. Here it is your red, here it is green, and here it is a blue. So if you take the yz as a reference plane, what will happen to your cylinder? Cylinder, it will x coordinate which shows you the one which is been specified over here. The y, here it is a z component, so this one we are having, that is 2.5. So what we have done, we have just shifted it to a distance, okay, with respect to your origin coordinate. Z coordinate is taken as 19 over here. So what is this z? So it has been shifted from this center to the second center, that is equal to 19. Okay, so this is what is been done. X coordinate is just 2.5. Just observe, here is this one. Okay, so minus 2.5 has been taken. Z coordinate has taken as 19. So you see the blue over here, so it has been shifted from this plane to this location. So this is one of the thing which is related for uh, say the first case. Now let's go with the next one, uh, the second one, the cylinder 3. So cylinder 3 over here is again this one. So you can see it is minus 2.5 over here. This is for your this one, because when we have generated the cylinder, so if you see this extrude operation which has been done, it is just run for 60. So what we have done is we have slightly cut the object which is on the bottom side, and then we have continued with the same. So this is one thing which is done. Now next thing is the cylinder 3 which is here. So again 65 is there, but the actual dimension will be the 60. Next thing is the cylinder 4th over here, then cylinder 5 available here. Next thing, we have done a boolean operation so that the casing will be made to be uniform for all of them. And next thing is we have generated the individual cylinders. So what is this now? This is actually your the lithium-ion cells which we have. This is 60 X component we have taken as a 60 available here. And then that is in, you can see again this is a red, this is X, so red is your X, and we have shifted this in X direction, that is in the 60. Okay, so this is how the orientation is there in the X direction which is available here. Then let's look at the cylinder 12. So again the X component I have specified, Z coorigin it has been shifted to 19. So whatever the plane we have generated, from that plane we have shifted it to 19. So this is the origin definition which you are changing to a certain extent in order to draw the second one. Now what we have done in cylinder 11 and cylinder 12, if you just see over here, instead of making add to frozen or something, we have made it slice metal. So that what will happen, whatever the earlier cylinders was generated like this 2, 3, 4 and 5. So this cylinder 11, 12, 13, 14, it will slice the existing cylinder which was present. Okay, so or we say that casing which was present, so it will go on to slice it, and so that what will happen, the outer layer which is been visible over here, it will act like a casing, and later on we are going to define it as separately in the we can say the will go on to name it specifically in the meshing, and at the same time when you proceed with the we say the fluent setup, that time we are going to specify the different material also. So that is one thing which can be done. Next thing is cylinder 12, as I said earlier, cylinder 13. So you need to shift it again. It is 38. So initially it was 0. This is 19, and second one will be 38. So now this is in the positive direction of Z over here. So just see the Z coordinate over here. So this is Z coordinate is a blue. So let's observe the blue component over here. So first is 19, and second will be over 38. Similarly 14. So this will be on the left hand side. So that's why you can see it is minus. So this was the plane, and from this plane it has been shifted to, let us say, on the left hand side. So that's why it is 19 as a minus 1. Next one, last one is 38. So it has been shifted on the, say again, left hand side. We have taken a distance that is equal to 38. So this is the origin definition where we are shifting the object with respect to your origin. Now what is origin in this case is we actually define one plane. So plane will be considered like a origin, and from that we are shifting the object either to the left or to the right. Just like in this case we have done it towards the left, and in earlier case we have done it towards the right. Remaining this is 60, and you can see the radius is 9. So this is a part of the thing. 11, 12, 13, 14 and 15, you observe all of them have done as a slice material option. Whereas if you go with the cylinder 2, cylinder 3, cylinder 4, cylinder 5, so this is again has been done as a slice operation. Now how these two slice operations are differ, we have generated first, this is a sketch. On that sketch we have done the extrude operation in y direction which is we are having. Then after generating the solid with the help of extrude, what we have done is we have created one more cylinder, and this is the outer one which is of radius 10. So it is we have done again the slice material option, so that whatever the channel we have, the channel will be sliced out. So that is what we have done in the first case. Cylinder 2 also we have done the same operation, that is a slice material. So which slice operation has been done, whatever this layer this channel we have prepared, this cylinder is actually slicing with respect to your channel. So there is a difference over here. This is 4 and 5, the same thing, we are slicing the channel over here. In the 11, 12, 13, 14 and 15, what we are doing, whatever the existing cylinder was there, we are slicing that particular cylinder at 11, 12, 13, 14 and 15. You can see the dimensions which are available. So we have used this specifically the slice material option so as to apply the boundary conditions properly when we are going for the next part that is related to setup. Okay, so let's understand what is the casing over here. So this is the outer casing which I have preferably name it here itself, so that there will not be any kind of conflicts, or there can be not be any kind of confusion in the boundary condition which we will be applying in the post process, in the setup, and as well as we will be specifying this in meshing. So this is how I specified as a channel. So how this channel was generated? The channel was generated by using a sketch, and then extrude operation was done, and based upon that the channel was generated. Then these are the cells 1, 2, 3, 4 and 5. So you will see, if go inside cell 1, 2, 3, 4 and 5. Okay, one thing which I have done over here is I just specified cell rather than specifying 1, 2, 3, 4, 5. Now what could have happened if we have specified it 1, 2, 3, 4 and 5? There could have been a difficulty in terms of applying boundary condition in the setup. Now where this difficulty will arises, I will just show you when I open the Fluent setup. Once this is okay, once this is complete, I will show you where the difficulty come out if I specify 1, 2, 3, 4 over there instead of specifying only cell. So better way, always specify it as cell only, not specify 1, 2, 3, 4, 5. This will be us we have form a part, so that we don't need to apply much boundary conditions over there. Okay, so this simulation was there, and just I will save the work before proceeding. Okay, so you can see around 1.196, this is the flow time which we have right now. How many time steps we are completed? We have completed around 2100 time step. Okay, so whatever the question I said, that instead of specifying 1, 2, 3 and 4, I just specified cell in the here. Okay, while preparation of geometry. Now how this advantage us, I will show you in the boundary condition. Now in boundary condition, what you will be saying, observing, it's just only wall cell, wall casing and wall channel. These are only one thing which is available, and you don't need to put boundary condition for each and everything if you are doing the way it has been specified in the geometry. So better way, try to specify as a cell only, don't specify 1, 2, 3, 4, 5, 6, 7, 8. What will happen otherwise? In the Fluent you will see cell 1, cell 2, cell 3, cell 4 and cell 5, cell 6 kind of thing, and you need to put boundary condition for each and everything. Okay, now this is one simple geometry where we have used only 5, but there are chances that if we are considering the actual model which involves lithium and battery pack around 70, 80 cells, so it will be quite a difficult task to enter values for each and every 70 cells. So that is one thing which you need to always remember when we are proceeding for we can say applying the boundary conditions. So the preparation has to be done right from the geometry itself, so that there will not be any kind of difficulties as far as the latter parts are being concerned. So casing has been specified here, this channel has been specified. Why cell has been become why cell we have formed as a part? Because again the same thing, we don't want to apply much boundary conditions in the setup, because that will be a quite tedious task to do so, and that's why it has been done as a form new part. And at the same time I have made it cell 1, 1, 2, 3, 4, cell only, instead of specifying 1, 2, 3, 4. So this is the first thing which is been done with the respect to your geometry. Now let's proceed with the next part, which is related to your mesh. Okay, so once your mesh has been open, you will see this is a casing which is there, then channel is there, and channel means this is the outer core which is there, and this is the last one which we are having is the this is okay. So this is the cells which we have. Now if you see cells, you can see 1, 2, 3, 4 and 5. Okay, there are total are 5. Again, I have not specified cell 1, 2, 3, 4 as a number over here. Instead I have just specified cell in each of the case. Okay, now next thing is here the mesh. This is a quite okay mesh. I will not say it is a very good mesh, but just to reduce the time which is required for simulation, because for whenever I done this is for a trial run, whether we are on the right way on getting the simulation result or not. That's why it's a comparatively better mesh has been selected. I will not say is a good mesh over here. This is just a default, we say quite better than the default one. You can see 3,15,865, this is number of nodes, and 22,71,841, that is your elements. So it's a okay mesh to proceed with, but later on you definitely can go and modify the mesh size as per the requirement. But again the computational time will go on to increase with respect to this. So as far as the trial runs are concerned, you can definitely go with comparatively a medium size of mesh, and try to get check whether the results are in the proper way or not, and later on it can be done with somewhat once you confirm that you are getting the results as per your expectations, then you can definitely go on to modify the mesh size and again complete the task. Okay, now this is the one thing which is done. Actually the geometry has been available here. Now it's part of mesh. Then you can see the element size which are selected is 0.001. Again, that some the element size which has been selected should be based upon your specification of computer also, because you must understand how your computer is, and accordingly we say you definitely try to apply the mesh. If your computer capabilities are not that much, you preferably to go with a comparatively smaller size of the comparatively we say um, a coarser size of mesh rather than going to too fine. So again the system may get hang while running it. So this is the one thing which you can try out before we can say you are having some kind of trial run. Now this is cell boundary, so you might not be in position to visualize it. So in order to visualize the cell boundary, I will need to do one thing is I will hide this one, and I also hide the casing. Okay, now you will if I click on cell boundary, you will able to see this cell boundary. So when you go on to select the geometries or specify a few things like the boundary condition which is will be useful for the setup. So I had done the name selection over here as a cell boundary. So once it is hide, then only you can see it over. So I make it show all bodies. Similarly, there will be inlet on this side I specified, and your outlet will be on the other side. So this is important because the computer will not be in position to understand at its own. We need to tell the computer which one is the inlet, which one is the outlet, which are the cell boundaries and other thing. So this is how the specific portion has been specified. In addition to that, I have not done here, but if you want, you may specify the casing also as a name selection, but that's okay to go with this. Okay, so this is the part which is related to mesh. One more time, this is the things which are visible here. We have generated a mesh which is 0.001. I may not say this is a very good mesh, but still okay as per the trials are concerned. Cell boundary, inlet, outlet. Now let's close this window and let's go with the fluent setup part. Okay, so we already run this, so I will just show you with what kind of models and other things which are being useful. So we have used the energy model over here. We have turned the energy equation on because definitely we are dealing with the temperature, so that's why energy equation is turned on. Then viscous standard K epsilon we have selected, enhanced fault treatment, thermal effect and curvature correction. So these options will be available when only the K epsilon model has been selected, the fault treatment, thermal effect and curvature correction. So that's why this has been selected. Now next thing is that we are done with the model. Now it's time to go with the material part. So material which we have done is water liquid, the fluid which is flowing through the channel. Second one is if you want you can use the air also. Air is the by default which is available. You can make use of air also, or you can go with the water liquid also, or you can add any other liquid from the fluent database. So there is the library has many things which are available. You can select the fluid of your choice out of it over here. Now next thing is related to your solid. Now I have selected nickel as because the lithium ions are normally coated with the nickel, so that's why I put it over here. Actually I selected this from the fluent database. You can see here, go to the fluent database and you can see the solids. So you can see n number of solids which are been available as per your requirement. You can go on to select out of it. So next one, um, aluminum again is the by default material which is available in the fluent database, so it will be as it is over here. In my case, when I prepared the casing, I have considered the casing to be made of material as aluminum. Somebody may select a copper also, or maybe some other material also, so it depends as an individual choice. So that is all related to material. Then cell zone conditions, I have not done anything. In boundary condition, as I said, you will see in inlet I have put some boundary condition as a velocity which is magnitude, that is 1 meter per second. So velocity is coming in, it is going out. So the fluid is coming in and the fluid is going out with a velocity that is equal to 1 meter per second. So that is the boundary condition I have applied. At outlet we are not applying any kind of boundary condition. As I said earlier, when you in the geometry itself we are putting the less things, just like a systematic thing which has been specified here, casing, channel and cell. So what will happen here in the setup, you are having only three major boundary condition where you are going to put the values. So let's see what is cell. I have applied the boundary condition at cell only. So you can see I have applied the temperature at the cell and accordingly it is visible. So for cell it is a nickel metal which you have selected. So that's why you have the option of selecting the material. If you added third material, you can select the third material also, depends. Now next thing is wall channel. Now what is wall casing? Okay, I will go with the wall casing here, and you will see the material is by default is aluminum. As I said earlier, I have considered the wall casing to be made up of aluminum. So accordingly, if the wall channel is somehow made up of different material, you can add that material and accordingly you can proceed with the process. So this was all related to boundary condition. Then I directly jump to the initialization over here. So what you need to do is you need to compute from inlet, and you need to click on the initialize button over here, and then later on you have calculation option available. In that calculation option, before proceeding to that, I have set the animation just like here. I have set for the contours of total temperature. I can show you going inside of this one. When you go it for the first time, you can click on new object. A new window will open over here, and depending on whatever the thing which you want to specify, just like I have specified total temperature, you can select the temperature and then you can select the total temperature out of it. So accordingly such options can be there. You can make use of that option. I already used the contour one, so I'm not going to change anything out of it. Next thing is the solution calculation activities. So if you are running the simulation for longer duration of time, you may put some values over here, that is 20 or something. Accordingly the simulation can be saved. Then next is the run calculation. So I selected the adaptive time set so as to prevent the problem of current number that can happen. So number of time step I have selected is 900. It is around, the time step size has been selected as a zero point 0.5. So depending on the mesh size, the time requirements will be more or less, uh, depend what you have selected. At the same time, whatever the mesh you have selected, you must select the time step size accordingly so as to avoid the problem of current number. Okay, let's have a trial run of, let's say, 50, and just make it run over here. So you can see the iteration process is going on. So this is the contours of total temperature. The flow time currently is 1.37. So if you want to compare the result with respect to experimental one or something like that, so in that case it might be necessary to run it maybe for a suitable time period, flow time. Just like if you are running the simulation, if you are having experimental setup and you are running it maybe for 10 minutes and you want to compare the result with the help of CFD, you can have this flow time around 600 seconds and so as to compare the results effectively with the experimentation as well as with the CFD. So this is 64% has been completed. Okay, so go back to workbench window, click on save button. Then go back to your Fluent window, click on Fluent, exit. So you can remember 1.1961, that is the flow time. You can go to the last part, that is result, click on edit. Okay, so this is already there. The contours, I just what things we are included. One of the thing which we have included is volume rendering. You can see here the option for volume rendering is here. So once you click on it, this will open and you need to select your variables. I have selected here as a temperature as a variable. Accordingly, as we are doing with the thermal analysis, so preferably we'll be looking for the temperature over here. Apart from that, if you are interested in velocity or maybe some other parameter, you can select out of it also. It depends on the what is the requirement of your resolution. I took around 100. You can take it higher also, or you can take it lower also. Higher the resolution, the time required for simulation will also be, time required for visualizing the simulation will also be some slightly more. Next thing is which is done is the streamline. The streamline option is here. So when you click on the streamline option, this will open. Now in that case, again we need to tell the domains, all domains from where to start. We are set as inlet. Color is the variable which we are interested in. So we are interested in temperature, so put down temperature over here and make it apply. So this is how the two things which has been done. Now say this is, if you want to add the flow time, you can go with the ABC option available here. Just go here, take it expression, say you need the time value. Let's select the suitable location. So let's take it left and say at the bottom, make it apply. You will see the time value here, 1.38577. Okay, so in addition to that, if you want something else, let's take this one here, say time step. If you are interested in location, I will take it center and then take it top. It will appear somewhere here. So likewise things are been done. Apart from that, if you want to add anything, like you want to add something as a date, you can add the date also. So let's take the location left and this take it top. So it is here. So in addition, you can add something else also, like make it here. I want to add the name here, file name. I will make it here as a, see this one. Okay, so I added frontiers and CFD. I take it center and I will take it, okay, I will take it right and I will take it center. So make it on this side. So likewise it can be done. If you want, you can add your something which is related to name also. So this is the first thing. Then if you want to visualize the things, let's go here. So this is the time step animation, out of which I will select the sweep animation option. Click on it, make it somewhat slow in order to visualize it in better way. Click on this. You will see the particles which are moving from one end to other end. Now while moving, you might have observed that the particles, the color contour for the particle has changed. Initially when it is coming from the inlet was all blue. Later on it is observed that some of them had changed the color, maybe to somewhat light, say green or kind of thing. So that indicates the heat has been taken up by the fluid particles from the cell over here. Whatever the heat is generated in the cell wall, cell through the casing, so that has been taken up away and the particle is moving from inlet to outlet. Okay, so this is one of the way of visualization. Another way of visualization I will try to show you, this one. Okay, just we need to wait till the time it is stop, otherwise the system may get hang. Okay, so I can stop, I can change the visualization of this also. Earlier we have shown like this. Let's have one more time. It will be just a fluid particle. So if you are more interested in observing how the fluid particles are moving, so in that case you can select the streamline like this by unchecking the volume rendering option. So click on this. Okay, so you need to wait. Okay, so this is done. In addition to this, you, if you want, you can save the simulation file also to the whatever resolution you want. Like you want it to be a different one, HD video 1080p, you can select it. In addition to that, you can select save the image files also for whatever the simulation your performance. Let's say you are done up to 2150 time step. So for each and every time step you can save the image file also. How this image file can be saved? You can go with the advanced option, save as image file. You can select the frame rates like 60 and the highest one. If you are saving it to directory, so the image file will also be saved. How the image files will always be saved, that can be even simple example by, once this is done you can go back and click on this and click on save movie option. The files will be saved in that particular folder. So here it is HD. Even you can go with the custom range also. Let's okay, so uncheck, I already uncheck. Now again you can see the last thing. So this is run for a very short time, that is around 1.3857 seconds. So this might not be that we can say a good time. You might have to run it for longer duration. Say if you are running it for at least 10 minutes, around 600 seconds, or if you are running it for 5 minutes, so it can be around 300 seconds. So 1.38 second is quite lower value, but just for visualization whether it is going in the right way or not, so that we can easily predict out of it. So this is one of the thing which is important as far as the complete tutorial of it.